Let's take a look at a couple of rational inequalities. So the first one is 3x plus 1 over negative x minus 6 greater than or equal to 5. Remember that in rational inequalities, we want to take all the terms to one side of the inequality, leave just 0 on the other. So in our case, we have 3x plus 1 over negative x minus 6, bring 5 to the left side, bigger than or equal to 0. So now we have to combine these terms. Remember, we have a rational term and a single term here, so which happens to be a constant of 5, negative 5. So we will combine them into a single rational expression. So which means that negative 5 is going to need a denominator of negative x minus 6 in order to join the first rational term here. So what that means is that we're multiplying, and now we have only one denominator, negative x minus 6, and in the numerator we're going to write 3x plus 1, and then minus 5x. Minus x will make a positive 5x, and then negative 5 times negative 6 will make a 30. One more step to make this simpler, so we'll combine the like terms, so simplify the numerator. You have 8x plus 31 over negative x minus 6 greater than or equal to 0. So there are different ways of solving these types of rational inequalities. One of them can be to factor out the negative here from the denominator. Usually we don't like denominators to be negative, but I think that I'm going to want to keep this the way it is because I want to explain something else which is important in solving rational inequalities. So once you have simplified the rational inequality into a single rational expression on one side and 0 on the other side, we will have to find the zeros of both numerator and denominator. So we have a linear expression here, so that's easy to find the zeros of. So we have x equals negative 31 over 8. Denominator is negative x minus 6, and that would be equal to negative 6. So there are two critical points, or two zeros, in this entire rational expression. And when we say zeros, we mean the zeros of the numerator and denominator, or key values we like to call them. And they are negative 31 over 8 and negative 6. So remember that what we want is that the sign of this entire expression here be positive. So in order to analyze what the sign of the entire expression is, we're going to have to look at the sign of numerator and sign of denominator. So for this, we build the number line from negative to positive infinity, and we place these zeros on the number line in order not to scale. So negative 31 over 8 is less than negative 6. So negative 6 will sit here first, and negative 31 over 8 here. Now we are going to list the numerator, 8x plus 31, and negative x minus 6 on the side, because we are trying to discuss the sign of each of them. Now remember that the sign of numerator and denominator will determine the sign of the entire expression. So down here we will have to discuss the sign of the rational expression, so which is 8x plus 31 over negative x minus 6. Now, the way that we study the sign of each of them is by looking into the zeros, because remember, the zeros will separate the negatives from positives. So for example, if you have a graph, right, that is crossing at 0, so on one side of the 0, let's say if this is negative 2, so on this side for these x values, the function will have, or the y values will be negative. And for bigger than 2, that will be positive, right? So these are things we have discussed in class as well. That's just a quick reminder for us, right? And the way that we want to do this quickly is by dropping a perpendicular here, because this is where the zeros of the parts of numerator and denominator are. And we know that 8x plus 31 will be 0 at this point, so we're going to place the 0 right here. And negative x minus 6 will be 0 right here. Now, If the numerator becomes 0, so remember numerator becomes 0, 0 divided by anything will be 0. So that will make the sign, the value of this entire expression equal to 0, and that's why we place a 0 right here. Now, if the denominator becomes 0, then we're going to have a number divided by 0 here. So a number divided by 0 is undefined, and this is the reason why we say that at x equals -6, the rational expression will be undefined. Now let's discuss the sign of each part of the rational expression. So 8x plus 31 has a 0 at -31/8. For values of x less than -31/8, and I'm going to take a funny number here, -100, let's say. So this will be a big negative then, plus 31, so it will be negative. And then once it crosses it's 0, it will turn to positive. And if we want to prove that or test this, we take a value of x equal to 100. So if 8 equals 100, then this will be a positive. Now, when we look at -x minus 6, remember this is a linear term, right? A linear expression. And as you can see, x has a negative coefficient, which means that if you were to graph it as a line, this would be a line that goes down, which means that prior to hitting the 0, the y values of the line on the line would be positive, and after that will be negative. Now, if we want to look at it from the algebraic, not just graphical point of view, but algebraic point of view, then what we can do here is we can take a value of x less than -6. Let's say, for example, -7 even. So if x is -7, then -7 minus 6 will be +7 minus 6. So that would be a positive. And once it hits the 0, or it passes the 0, let's say, for example, a number from -6 to infinity, number 0, right? So if you have 0 minus 6, that would be negative. So we're going to say that from the division of a negative with a positive, which happens for x values from -infinity to -6, we're going to get a negative sign for the expression. For the division, negative divided by a negative, two negatives divide to positive, and positive divided by a negative will give a negative. Now, what we were looking for is the values greater than or equal to 0, and it seems that greater than or equal to 0 will happen between -6 and -38/1. So our solution for this inequality here will happen right at these particular x values. So we're going to say that the x values have to be between -6 and -31/8, because that's when the entire expression will be positive. Now the next question becomes, how about 0? Because as you can see here, we have greater than or equal to 0. So you see that the expression can be 0, so the entire expression can be 0 at -31/8, so which means that we are going to include this number in the solution, and the way we do it is by putting square brackets around it to indicate that this is included in the solution of the inequality. Whereas -6, even though we want zeros, that's not the right 0. This is a 0 denominator. That's a restriction, and that's why we have to restrict this. And this will be the solution to this inequality. Stay tuned for the next one. So we're going to take a look at x plus 1 over x minus 2 less than x plus 3 over x minus 4. Thanks for watching.